Einstein used deduction to prove that time slows down when moving close to the speed of light. He made this incredible proof only using two facts. Fact 1, that the speed of light is always 300 million meters per second, and fact 2, that the laws of physics are always the same provided your velocity isn't changing. He then built up his argument using a thought experiment that went something like this. Imagine a rocket travelling at a constant velocity close to light speed. On this rocket, a man is calculating the speed of light by bouncing a light pulse off a mirror to a detector. He measures the distance moved by the light pulse and the time it takes to reach the detector. Finally, he calculates the speed of the light pulse using speed equals distance over time. Einstein then made his first deduction. If the speed of light is always 300 million meters per second, then the man must calculate the speed of light to be 300 million meters per second. This seems obvious so far. But now imagine a stationary woman looking in on the fast ship. She does the exact same experiment. She measures the distance moved by the light pulse and the time taken. She then uses speed equals distance over time to calculate the speed of light. Einstein then deduced that if the speed of light must always be 300 million meters per second, and the laws of physics are always the same when your velocity isn't changing, then she must also calculate the speed of light to be 300 million meters per second. So far, he deduced that both the fast and the stationary scientist must both calculate the same speed of light. But he realised that this was rather strange. Why? Due to the movement of the rocket, the stationary scientist sees the light move a much greater distance than the man does. But if they both calculate the same speed of light, how could the light pulse take the same amount of time to travel a greater distance? Well, the answer is, it doesn't take the same amount of time. Einstein deduced that the only way for both of them to calculate the same speed of light while she measured a greater distance is if she also measures a greater time for the light pulse to enter the detector. This is because speed equals distance over time, so if the distance is bigger, then the time must also be bigger to get the same speed of light. Think about it. The exact same event appeared to happen quicker for the fast-moving man than for the stationary woman, and from the stationary woman's perspective, his clock appeared to be ticking in slow motion. Hence, Einstein used deduction to prove that time slows down when moving at high speeds, and he called his prediction time dilation. He even came up with a fancy equation for it. And since his incredible prediction, highly accurate clocks placed in orbit have been shown to tick slower than those on Earth. Thank you for watching. Please like and subscribe for more maths lessons and worked examples.